All right. Good evening and welcome to today's class. Actually, we've been discussing trigonometry, and yesterday we solved some examples. At least with the few examples we solved, I believe one can be able to attend to so many other examples that comes in the same line. Okay. Now, before I go to today's topic, let me chip in something, please. Let me chip in. Having discussed trigonometric ratios, all right, which we call sine, cosine, and tangent. Now, if I say, for example, now that sine theta is equal to, let's say, 2 over 3, for instance, 2 over 3, okay? Okay, let me write. Assuming as when we assume that, let's say, sine theta is equal to, let me assume 3 over 5, okay? Then what will sine square theta be? It is nothing strange. It means that this thing is squared now, okay? It means this is equal to 3 over 5 squared, which is equal to 3 power 2 is 9, 5 power 2 is 25. That is all about that. So in case you see anything squared, don't panic. This is what it is, okay? Now let's look at this particular, let's look at complementary angles as regard trigonometric ratio. Now, two angles are said to be complementary, okay, if their sum is equal to 90 degrees. I repeat, two angles are said to be complementary angles if their sum is equal to 90 degrees. Let me give an example using this diagram. This is a right angled triangle. This is a right angled triangle. Now this shows angle 90. Okay. Now let's assume here is angle theta. Maybe, okay, I want to explain this thing now. We said now, listen, here is always constant as 90 degrees. Okay. That makes this into be a right angled triangle. Now look at this place now. If these two places are complementary, that means the sum of the angle here and the one here must be equal to 90 degrees, right? Now, that means if here is theta, what will here be? It's more like saying that the sum of two siblings or two friends, all right, the sum of their ages is, let's say, 80. Now let's assume one person is 30 years. The other person will be what in age? If one is 30, all right, the other person is going to be 80 minus 30. This is where to get second, which becomes 50. Is that okay? So that means if here and here are complementary, show that their sum is 90 degree. Now here is already theta. That means here is going to be 90 minus theta. All right. So that is that. Let's continue now. If I name this triangle, let's say this is how do I go? Okay, let me just change it. Let's say I have B. Okay, let me just put this one A. You can pick anyone, please, but I have my personal reason. This is A, okay. This is B, and this is C. All right. Like we always know, this side facing here is small b, here is small a, here is small c. All right. Good. Here already is 90. This angle C already is 90. It's constant. Now, angle A is theta, while angle B is 90 minus theta. Okay. Now, let's actually employ, what was it again? SOHCAHTOA, which is what we always use to express relationship between the trigonometric ratios. SOHCAHTOA. Already we know what these things mean. In our first class, it was discussed. So let's say I have, as usual, I have that S is sine theta, okay, which is equal to opposite over hypotenuse. Let's assume that this is my reference angle. That means this is my opposite hypotenuse, which is A over C, is equal to A over C. Okay. Now, my C here is cosine. So cos theta is equal to adjacent over hypotenuse. Adjacent over hypotenuse, which is B. Okay, let me just write adjacent over hypotenuse, which is B over C. Then tan theta is opposite over adjacent. Opposite over adjacent, which is equal to A over B. Let's continue. Let's continue. Now, let's go from here. We have seen that sin theta gave us A over C, cos theta gave us B over C, while tan theta gave us A over B. Okay. Now, what if this place is our reference angle? Okay. Now that means when we're working with this place now, our sine becomes sine 90 minus theta degrees. That means here becomes my reference angle. That means here will be my opposite, adjacent and hypotenuse. Now, sine is equal to opposite over hypotenuse, which is B over C, which is equal to B over C. All right. Now, cos 90 minus theta. All right. Now, cos is adjacent over hypotenuse. Here's my adjacent, then hypotenuse, which is A over C, which is A over C. Then my tan 90 minus theta, tan is equal to opposite over adjacent, which is B over A. Let me use this line to separate. All right. Now let's look at one or two things here. Now, if you watch here now, from the first one, sin theta is equal to A over C. At this place, cos 90 minus theta is equal to the same A over C. So we're going to have that, then in summary, we have that sin theta is equal to cos 90 minus theta, which is equal to A over C. Now watch here, cos theta is equal to B over C. Abi? Now my sine 90 minus theta is equal to B over C. That means this is equal to this. So I have that cos theta, all right, is equal to sine 90 minus theta, which is equal to B over C. So in tan, we don't have the same thing in tan. Okay, so tan stays where it is. So this is what I want us to derive today. By tomorrow, we are going to work with these two things that we just derive. So please, before tomorrow, try to memorize this thing we are saying here, okay? Sin theta is equal to cos 90 minus theta, while cos theta is equal to sin 90 minus theta, okay? So please, this is what I want us to really focus on today, these two things here. By tomorrow, we are going to work with them. All right, thank you for being part of today's class. Bye for now.